Hello and welcome to another math edition. Today, this is Friday's lesson. We're going to take a look at finally how to solve simple linear equations. So every single exercise we did up to this point were some of the building blocks to linear equations. And linear equations is quite simple. The aim of the game is to find out what the missing value is. So in other words, what number is the number when you go 3 times the mystery number plus 1, and that gets you 10. So in other words, we're just figuring out what the value of x is. If you compare these equations to what we were doing previously, we were doing expansion, simplifying, all that sort of stuff with just expressions. Linear equations, we've now got the equal signs in. So another way to rephrase this is, what number times 3 plus 1 gets you 10? Well, there's a systematic way for us to actually solve this. If you figured out, well, 3 times 3 plus 1 gets us 10, and you've already figured out that x is 3. Unfortunately, that sort of method probably won't work later on when we deal with harder linear equations. But for now, some of these, I'm sure you can guess straight away what the number is. Like 4 take away 3 times the mystery number equals 7. You might be able to figure that off the top of your head. But here's a way to figure it out. And whenever we deal with linear equations, we inverse BIDMAS. So if we write the acronym BAS-DMI, this sort of gives us the order of elimination when we're dealing with linear equations. So here we've got 3x plus 1 equals 10. What we have to think to ourselves is, well, this first line of working, let's erase that. That's not meant to be there. This first line of working, we're going to use the therefore button, or the therefore symbol, so we don't have overlapping equals, or we don't want equals and then equals. Do we have any brackets in this linear equation? No, we don't have any brackets, so we can cross a B out. Do we have any addition? So purely addition terms. Yes, we do. We have a plus 1. So what we do here is, to deal with this addition, we inverse it and chuck it to the other side. So our first line of working, we've got 3x. Remember, we're going to chuck this positive 1 to the other side and turn it into a negative 1. So this positive 1 has just turned into a negative 1. Right? And then we can cross that out and simplify. So therefore, we know 3x equals, well, this part here would get us 9 because 10 take away 1. Do we have any subtraction? No. Do we have any division terms? No. Do we have any multiplication? Yes, we do. Can you point out where the multiplication is? Multiplication here is the 3 times the x. So therefore, what we do is, we would chuck the times 3 and throw it to the other side and turn it into a divide by 3. So if it's plus, we throw it to the other side as a minus. If it's a minus, we would throw it to the other side as a plus. In our case here, if it's times, we would throw it to the other side and turn it into divide. So therefore, our third line of working, what we're going to have is x equals 9 divided by the 3. Divided by the 3. Okay, or you could write divide by 3, up to you. I prefer fractions. And what we get here is, therefore, x, well, 9 divided by 3, we know that gets us the answer 3. If we think about it, does 3 times 3 plus 1 get us 10? Yes, it does, because 3 times 3 is 9, plus 1, that gets us 10. So our mystery number here is 3. And that's all linear equations is. We're figuring out the missing number. All right, so let's rule that off and move on to the next part. So we rewrite our acronym BASDMI. We think to ourselves for the second example, x on 2 take away 5 equals 6, slightly harder, maybe a bit harder to see. Do we have any brackets? Nope. Do we have any addition? Nope. Do we have subtraction? Yeah, we do. Here's the subtraction. So the subtraction here is the -5. So what we want to do is we want to throw the negative to the other side and turn it into a positive. And so our first line of working would look like this. So the x on 2 stays. The -5 is chucked to the other side. We've got our 6 that was on the previous, on the other side. And the -5 turns into a +5. Right, so if we draw a line out here, that's where it's gone. We can simplify the right side here, and we know, well, x on 2 equals, this part here is 11. So x on 2 equals 11 because 6 plus 5 is 11. Then we can finally cross out the s. Now, do we have any division terms? Yes or no? If you answered with yes, you are correct. Here's our division term. So it is being currently divided by 2. What we then do is the opposite of divided by 2 is times 2, and we would chuck the times 2 to the other side. So how this would look is we have x by itself on the left. We chuck, let's erase that for a moment. We would chuck the divide by 2 on the left side to the right side as times 2. So this would then turn into times 2. All right, and whatever 11 times 2 is going to be our x. So therefore, our 3 dots is therefore equals 11 times 2 gets us 22. So if we think about it, 22 divided by 2 gets us 11. 11 then take away 5 gets us 6. So we know 22 is exactly where the x would go. All right, and again, that's all linear equations is. We're just figuring out the missing number. Let's move on. Let's write our acronym again. BASDMI is our linear equations. BidMaths, but BASDMI. And we think to ourselves, do we have brackets in example C? No brackets. Do we have any addition terms? Yes, we actually do. Can you see where the addition term is? If you said the +4 here, you are spot on. So the +4 here is actually an addition term. So what we then would do is, if you know, great. If you don't, we would then throw the +4 to the other side and change it to a -4. So what's left on the left is -3x equals 7. And then this +4 here, we would go and chuck it to the other side and turn it into a -4. So previously it was a plus on the left, throw it to the other side and change it to a negative. If you wonder how this magic works, I'll explain in another video. But for now, just know this is how it works. We simplify the right side because here we've got -3x on the left. And then this on the right, 7 take away 4 gets us 3. And we can cross out the a. Do we have any subtraction terms? No, because this is actually -3 times x, so it's not a subtract 3. Common error. Do we have any division? No. Do we have any multiplication? Yes, we've got a negative. We have a negative 3 times x. Okay, so what do we do here? Any ideas? What's the opposite of multiplication? Division, correct. If you answer division, well done. So, contrary to the addition and subtraction, when we throw across multiplication or division, so in this case, the negative 3 times x, we throw it to the other side. What we're actually doing is we're not actually going to change the symbol to a negative to a plus. We just chuck it to the other side purely as it is, like so. And that's going to get our final answer. Again, if you figure out, if you're questioning why, I'll explain in another video. Just for now though, whenever you throw a negative multiplication or a division across, it stays negative. So here what we have is x would equal negative 1. All right, so if you think about it, does 4 take away, or 4 and negative 3 times negative 1 gets us positive 7? Yes, because negative 3 times negative 1 gets us a positive 3. A 4 plus a 3, or a 4 and a positive 3, they combine to get you a 7. That's all the explanation for today. I know that might be a little bit complex, so make sure you send through any questions you have. Let's jump to the questions now. We are up to exercise 2D, and please have a go at 1, 2, and 3 every second question. That's all for Friday. Once again, please comment down below if you have any questions, and have a great weekend if you don't talk to me since.